Now that we have some ideas about the graphs of some basic logarithmic functions, let's see if we can't find out some properties of the graph of transformations. So here we asked to find the domain and the range for log base 7 of 2 minus 3x plus 7. Now in this problem, although I will use some ideas about transformations of functions, I'm not necessarily going to graph this transformation in order to answer these questions, but I will use ideas about transformations. Let's start with the domain. So the key to finding the domain of some transformation of a logarithm is to recognize that whatever you put into the logarithm has to be larger than 0. That is, when you evaluate log base 7 of something, this something has to be bigger than 0 in order for you to get an output. And we'll use that fact here. So whatever I put into the logarithm, in this case 2 minus 3x, I've boxed it, that's what I'm putting into the logarithm, that has to be larger than 0. So what I'm going to do is I'm going to say, well, 2 minus 3x has to be bigger than 0. Now I can figure out, by solving this inequality, exactly what the domain is. So solving this inequality for x, we can subtract 2 from both sides. We get negative 3x is bigger than negative 2. And then we can divide both sides by negative 3. And when you divide or multiply by a negative in an inequality, the inequality sign flips. So specifically, since this negative 3 is negative, I'm going to flip the inequality sign, and I get that x is less than negative 2 divided by negative 3, which is 2/3. So the domain is all x's less than 2/3, or in other words, in interval notation, minus infinity comma 2/3. And since it's strictly less and not less than or equal, I'm going to put a parentheses on the 2/3. Now let's move on to the question about the range. So in order to answer the question about the range, all I'm going to do is I'm going to observe that we have some transformation of log base 7. There's a horizontal shift, horizontal reflection, horizontal compression, and a vertical shift. But all of those transformations are not going to affect the range because the range is all real numbers. That is, if you take our graph, and I'm just going to draw a sketch of what the graph of log base 7 of x looks like. If you take this and, for example, if you flip it, then you get something that looks like this. And while that would change the shape of the graph, it doesn't change the range. If you flipped it in the horizontal direction, like what happens in this problem, also the range is unchanged. The range is unchanged because if you draw any horizontal line, you get intersections with the entire graph. And all of these transformations that we are applying, and more generally, any of the basic transformations that have been talked about in this course that you could apply will not change the range, since the range is all real numbers. Thus, the range is all real numbers, minus infinity comma infinity, and this will be the case for any transformation of a logarithm function.